Hi, it's Mr. T here. In this series of videos, I'm going to go through how to answer exam questions so that you get the best out of your writing when you're sitting exams. If you find this video useful, don't forget to click a thumbs up, subscribe, and then click that bell for notification if you want to see the next video. Hi, in this video we're going to look at and explain how to distinguish between primary alcohols, secondary alcohols, tertiary alcohols, aldehydes and ketones. In particular, we're going to just revise the acidified dichromate, acidified permanganate test, and look at the Lucas Reagent test, the Fehlings or Benedicts test, and the Tollens reagent or the silver mirror test. And going to use those different tests to identify those 5 different types of organic molecules. At the end of the video, I'll go through an example exam question you might need to answer, and specifically it's focusing on level 3 NCEA organic chemistry paper. Okay, let's look at some tests we use to distinguish primary, secondary and tertiary alcohols and aldehydes and ketones from each other. So the first test we can use is one you might be familiar with, is adding acidified dichromate to a sample. So we take a sample, we add some dichromate solution that's been acidified. Now you can either do that by adding acid to the dichromate, or adding the dichromate solution and then adding a wee bit of acid afterwards. So when we add that to the sample, we then put it into a water bath that's at say 70 degrees Celsius, and we will sit that in there for about 5 minutes. Now what we're looking for the positive test is this solution turning a green color. If it goes to completion, it's going to look more blue than green, and if it's only started to react, it's going to look a mixture between a green and an orange color, because it still has a bit of both colors present. So this means that our sample has been has been oxidized, and there are two this is generally a positive test for something that can be oxidized. That is either a primary alcohol like this. So here we can see this is a primary alcohol because we have the O8 functional group here attached to one carbon that is only attached to one other, and it turns into a carboxylic acid. Or we could have a secondary alcohol here. Remember, this carbon that the OH is attached to 2 other carbons, and it will turn into a ketone. Now remember, when a primary alcohol turns to a carboxylic acid, there is an intermediate of an aldehyde in between. So actually acidified dichromate will oxidize the aldehyde as well. So it will oxidize both a primary, a secondary and an aldehyde. It will have this positive color change. It will not react with a tertiary alcohol, and it will not react with a ketone. Okay, let's have a look at acidified permanganate. Exactly the same type of test. It will not react with a ketone, it will not react with a tertiary, but it will react with a primary, a secondary and an aldehyde. So we take the sample again, we're going to add acidified permanganate. It's a purple color. If we put it in the water bath for 5 minutes, it's going to go to a colorless solution. Now this is a positive test for a primary alcohol going to carboxylic acid, or a secondary alcohol going to a ketone. Remember, it's also a positive test for an aldehyde going to a carboxylic acid. Right, Lucas Reagent is another type of test we can use. Now this is a wee bit different. It's a positive test or a definitive test for a tertiary alcohol. Now the way that Lucas Reagent works is it's a substitution reaction, and the substitution reaction is more likely to occur the more carbons that are joined to the carbon that has the OH functional group on it. Now we take a sample, we add concentrated hydrochloric acid. Often we also add another catalyst called anhydrous or zinc chloride, that is zinc chloride without water. And then the solution goes this cloudy color if it's a tertiary alcohol, and it goes a cloudy color quite quickly after a couple of seconds. we say it immediately goes cloudy. If this happens, we have identified a tertiary alcohol. And actually what happens in this reaction is the alcohol group is replaced by the Cl to produce a chloride group, and the H and the OH get together and make water. And it is the two products of the haloalkane and the water, when you make those and they are together in the same solution, they don't dissolve in each other, they're insoluble, they're immiscible, so they produce that cloud. It happens that primary alcohols will not react with Lucas reagent. Secondary alcohols will go cloudy slowly over time. So it's harder to recognize the secondary alcohols, but you can get to a situation where you become comfortable with identifying their transition. Okay, we can also do another type of test, and this test is, there are actually two of these tests. We have the Benedicts or the Fehlings test, which is used to identify if an aldehyde is present. Now, an aldehyde will change to a carboxylic acid if it is, it only takes a very small amount of oxidation, a very low strength oxidant, to turn an aldehyde to a carboxylic acid. So we can use a Fehlings test or a Benedicts test. It will change an aldehyde to a carboxylic acid, but it will not change a primary alcohol to an aldehyde, and it will not change a primary alcohol to a carboxylic acid. So this test is only a positive test for an aldehyde. So what we do is we take the sample, we add our Fehlings solution or our Benedicts solution, we heat in a water bath, 70-80 degrees, 5 minutes, and it goes orange, blue to orange. That is the positive observation here. Now remember, that only works with an aldehyde. What happens is the copper ions in solution turn to copper 1 oxide. Okay, so its oxidation number is just 1 now, which is an orange solution. And this is only works with aldehyde. So it's a really good test for aldehyde, and so is the next one we're going to look at. Okay, the next test we're going to look at is called a silver mirror test. And that's when we use Tollens reagent. So I've got some silver nitrate here. This is just how I produce Tollens reagent. So I add to that some sodium hydroxide. It makes a brown precipitate. I then add some ammonia, concentrated ammonia, until the precipitate dissolves. And now that is Tollens reagent. And I'm going to add this Tollens reagent to my aldehyde and then heat it. So I take my sample of Tollens reagent, I take my Tollens reagent that I've just made, I add my testing sample, that is my aldehyde, or what I think could be an aldehyde, and then I place it in a water bath and I leave it there for about 5 to 10 minutes. If an aldehyde is present, a silver mirror will appear on the inside of the glass and it will reflect back as a mirror would. And this is why this is called the silver mirror test. Now this test is definitive, that is, so it only works with an aldehyde. Now you might not get a perfect silver mirror, but you will get parts of the glass that is silver, and that is still a positive test for an aldehyde. So what's happened is, basically there are, at the start there are silver ions. Those silver ions get changed to silver metal that is deposited onto the inside of the glass, and at the same time the aldehyde has been changed to a carboxylic acid. So this is a specific test for an aldehyde, positive test for an aldehyde. Now, right, so here's an example of the type of question that we might have. This is from 2023. This is question 2, and the question asks us the following. A student's got 2 test tubes. One contains propane 1-ol and the other one has propane 2-ol. The student adds acidified potassium permanganate to each test tube and warms them in a water bath. Describe the color change. In this question we need to remember what is potassium permanganate, and hopefully remember it's purple, and that for a positive reaction it goes to colorless. And when we look at propan-1-ol, it's a primary alcohol, and propan-2-ol is a secondary alcohol, so they're both going to react with our potassium permanganate. So we can just write the following sentence. Both solutions would change from a purple to colorless solution. The second part here says, explain how Tollens reagent could be used to distinguish propanal and propanone. Now we know that propanal is an aldehyde, and that Tollens reagent is a definitive test for an aldehyde. That is, it will only react with propanal. It won't react with propanone. And we know that Tollens reagent is sometimes called the silver mirror test, so it's going to produce a silver mirror. So Tollens reagent is added to both samples, and they're heated in a water bath. So we're just saying what we would do. Propanone would have no reaction, and there will be no observed change. Okay, let's bring it home. So what would happen to the other one? Propanal would be oxidized. So we're saying what type of reaction it is to propanoic acid, and a silver mirror is deposited on the inside of the glass test tube. Now let's check we've answered all the bullet points. Do we write the observations? Yes. Do we talk about the type of reaction occurring? Yes. Oxidation. Did we give the structural formula? No. So I could have just written the structural formula after propanoic acid. I could have just put comma and written the structural formula, but I've just written down an equation down the bottom. Now we could have just drawn the product on the right hand side, the organic product, because that's all they wanted. So what do we get for the answers here? Well, if we observed both alcohols correctly, okay, so that's the first part, or we correct observations for Tollens reagent, we get an achieved point. So either one of these correct gives us the achieved. If we explain that how Tollens reagent can tell the difference between propanal and propanone, that is, if we fully covered all of these bullet points, they give us a merit point.
Okay, if you've got to this part of the video, you've obviously watched all the examples that I had on those 3 questions. Hopefully this has fortified your understanding of geometric isomers, and you are now well prepared to go and attack that exam. Good luck, and if you found this video useful, don't forget to like it, subscribe, and look out for new videos that I might put up by clicking that bell. See you later.